Leetcode 207 Course Schedule. You have a number of courses and prerequisite pairs. Pair A, B means you must complete course B before course A. In the graph we draw an edge from B to A, return true if you can finish every course, and false if the rules contradict, for example when two courses each need the other first. Example 1, only 0 before 1, you can finish both, so true. Example 2, 1 needs 0 and 0 needs 1, nobody can go first, so false. Think of prerequisites as directed edges, each one says who must come before whom. Finishing every course means finding an order that respects all those edges, a topological order. That works unless the rules contradict themselves, like needing A before B and B before A, so nobody can start. That's prerequisites looping in a circle. Cons BFS, repeatedly take any course whose prerequisites are already satisfied. If you can do that for every course, you're done. If some courses are never freed, the rules loop and no schedule works. Two phases. Phase 1, build the directed graph from prerequisites. For each pair A, B meaning take B before A, add edge B to A, plus adjacency list and integrity per course. Phase 2, assuming you already know cons topological sort, run it on that graph. Keep a counter taken, add 1 each time you dequeue a course. If taken reaches number courses, return true, if not, prerequisites loop. In this solution we do 2 walks. First example, 3 courses with a valid schedule. We show phase 1 building the graph from prerequisites, then phase 2, cons algorithm with an in-degree array, think of it as a fixed-length array indexed by course ID, or the same values in a map, plus a queue of ready courses and a taken counter. Second example, 2 courses that need each other first, we will see the queue empty while in-degrees stay positive, which means a cycle. Phase 1 for example 1. Each pair A, B means an edge from B to A, together these edges form the prerequisite graph on the right, 3 nodes, edges from 0 to 1, 0 to 2, and 1 to 2. Phase 2. We keep an in-degree array, index I is how many unfinished prerequisites course I still has. Initially that is 0, 1, and 2 for courses 0, 1, and 2. Only course 0 is ready, so the queue contains 0 and taken is 0. Dequeue course 0 and process its outgoing edges. We decrease in-degree of 1 and 2 by 1. The array becomes 0, 0, 1. Course 1 now has in-degree 0, so it joins the queue. Taken is 1. Dequeue course 1. We relax course 2, its in-degree drops from 1 to 0. The array is all zeros. Course 2 enters the queue. Taken is 2. Dequeue course 2. The queue is empty. Taken is 3, which equals number courses, so every course was scheduled and we return true. Example 2. Prerequisite 1, 0 and 0, 1 mean edges 0 to 1 and 1 to 0, a 2-node cycle in the graph. Phase 2. The in-degree array is 1 and 1, each course still waits on the other. There is no course with in-degree 0, so the queue is empty and con cannot take a first step. Taken stays 0. Taken never reaches number courses. We stop with an empty queue and return false, the prerequisites contradict, which for a directed graph means a cycle. Time and space are both linear in the number of courses plus the number of prerequisite edges. Pseudocode for course schedule using Kahn's algorithm. Build the adjacency list and indegrees from prerequisite pairs a, b points to a, put every vertex with indegree 0 in a queue. While the queue is not empty, pop a course, increment taken, and lower indegree of neighbors. If a neighbor reaches indegree 0, enqueue it. At the end, return whether we took every course.